This is section 10.4. Section 10.4, we're going to focus on slope. In our last section, we focused on like intercepts. By the way, if you came in a little later, the pacing guide is finalized online. So if you want to print that out so you know exactly like what's going on, you can do that. There weren't really any changes from the other day. I just made it a little more detailed. But, all right. So slope is really, really important in algebra, and it means a few different things. One thing that slope means is rise over run. You might have heard that before. Rise meaning the top number tells you whether you go up or down. Run, the bottom number tells you whether you go left or right. Rise is also the change in the y value over the change in the x value. Delta is that triangle, that just means change. The formula that we typically use is we subtract the y values over we subtract the x values. And then top number tells us whether we go up or down. Bottom number tells us whether we go right or left. The top number is positive, we go up, negative, we go down. The bottom is positive, we go right, negative, we go left. So that gives you a few different ways to think about slope. When we're looking at a graph, let's say when reading a graph, just like reading a book, we always go from left to right. So if you have a line that's going up from left to right, the slope is positive. We use M to represent slope. If the line's going down from left to right, the negative slope. If you have a vertical line like this, we say that the slope is undefined. We get an undefined slope when we have 0 in the denominator. And we get a horizontal line if the slope is 0. We get a slope of 0 if 0 is in the numerator. Right. Those are some basics of slope. One other thing is typically with slope, it's a fraction. So slope is a fraction. And if not a fraction, we write over 1. But for example, if you get a slope is equal to 2, you could also say it's 2 over 1. That's what I'm trying to say there. So let's do a few problems where we're finding the slope. And let's say we have -3, -5, and -2, -1. And we're finding the slope. Well, I told you a few different ways to think about slope. One of those with this formula, where it's y2 minus y1 over x2 minus x1. But what we would do is just subtract the y value, so -1 minus -5 over, you subtract the x values, -2 minus -3. It doesn't matter what order you subtract them in as long as you subtract them in the same order. -1 plus 5 is 4, -2 plus 3 is 1. So I would just say the slope is 4. You could also write 4 over 1, it means the same thing. More of these. What if we had 2 comma 4 and 2 comma -6? And we wanted to find the slope. Same thing as before. -6 minus 4 over 2 minus 3. It looks like we get 0 in the denominator. What did we say 0 in the denominator was? Undefined. So this would be a line that looks like this. This one would be a line that looks like this. Positive slope goes up from left to right, defined slope is vertical. All right. What if we had 2 points like this? If I put a point right here at -5 comma -2, and I put another point right here at 2 comma 3. So instead of writing it out like we did, if they're on a graph, well, one thing we could do is we could do exactly the same thing we did before. We could just do 2 comma 3, -5, -2, and subtract them. And we'd see that the slope is 5 over 7. I mean, that's one thing we could do. Something else we could do is, I mean, remember, this would be a line. Obviously, it's going up, so we know we're expecting a positive slope. How many would you have to go up to go from -2 to +3? How many would you have to go up to go from -2 to 3? 5, right? So we're going up 5. And then how many would you have to go to the right to go from -5 to +2? I mean, we could have just counted, right? Up 5 and right 7. We could have just counted to get it, or we could have used the formula. So sometimes in algebra, there's like a few different ways to get the answer. To some people, they don't like that. They're like, just show me one way to do it. I don't want to know all these other ways. But in algebra, you kind of have to sometimes decide which way is best for you. Now, one other thing I'm just going to note here is if given an equation, we could write or rearrange in slope-intercept forms to find the slope. And y would be mx plus b. That slope-intercept form, this is the slope. I'm just throwing it in there because the way that my math lab is there's some problems in section 10.4 where if you just rearrange the equation, like you could figure out the slope, but we talk more about this in the next section. So, it all kind of flows together, but just so you know, slope intercept form, the number in front of x, of course, is your slope. How many of you already knew that? Yeah, okay. We'll talk about that in the next section. So, a few other things we have to talk about. I was talking a little earlier about parallel lines. Parallel lines have the same slope, and they never touch. Typically, we use this symbol to represent parallel lines. Perpendicular lines think about this, like perpendicular has two p's, so there's two things that happen here. They have the opposite and the reciprocal slope, and they cross at 90 degrees. So they typically look like this. A perpendicular line would be like, if one slope was 2/3, perpendicular slope would be -3/2. So it's opposite sign, and reciprocal means you switch the top and bottom. So what I'm going to do is I'm going to ask you to determine if the following lines are parallel, perpendicular, or neither. So I'll have y is equal to 1/2 x minus 3, and y is equal to -2x. So this would be an example like before, where we want to get it in slope intercept form. That's the easiest way to do a problem like this. So we want to try to get the y by itself. This would be the slope of this line. -2 will be the slope of that line. Obviously, they're not the same, right? I can make -2 -2/1. I can control the right slope as a fraction. Are they perpendicular? Yeah, right. They're opposite signs and they're the reciprocal. So these are perpendicular. And try something else. About 3x plus 2y is 6, and 2x minus 3y is 12. We're gonna have to do a little bit of work here. We have to get the y by itself. So what you could do is subtract the 3x on both sides. And then divide everything by 2 to get the y by itself. And now we can see the slope is negative 3/2. Second problem, let's subtract the 2x on both sides. Divide by negative 3. So y is equal to 2/3 x minus 4. The slope for this would be 2/3. Obviously, they're not the same. Are they perpendicular? Yeah, I think they are, right? Because one's negative, one's positive. And 2/3 and the 3/2, they're switched. So this is another perpendicular example. And the problem with this is, what if we had y is equal to 1/3 x minus 2 and y is equal to 3x plus 1? Looks like it's already in slope intercept form. It doesn't look like the slopes are the same, so they're not parallel. Are they perpendicular? No, I don't think so either. So these, we would just say this is neither. My pace. Am I going too fast? Good? Too slow? Can you guys give me some kind of feedback? All right. I see. Maybe I'll, yeah, all right, I'll try to slow down a little bit here. We're almost done with this section. Last type of example, I'll just ask you to find the unknowns. What if I ask you to find the pitch of a roof? And the house looked like this. And it doesn't matter if you can just run a house like that. You don't have to change your notes, but the idea is that the slope is like that, right? So when we're talking about pitch of a roof, we're really just talking about the slope. So to go from this point to this point, looks like we have to go up 5. And then to the right 3. Remember when we talked about slope? Top number tells you whether you're going up or down. The bottom number tells you whether you're going right or left, depending on if it's positive or negative. If you're going up 5 and to the right 3, that's the pitch. Pitch just means the stroke. The last one for this section is the grade of a ramp. When we're talking about the grade of a ramp, this means as a percent. These are kind of like really easy problems. But these are the kind of word problems that you'll see. It's a good thing they're easy. The grade of a ramp means slope. So this is going to be up 7/13. As a decimal, that's 0.53 or 53%. That's what they're looking for. So